In this video, we will see the second part of Python programming. It includes the scope of variables, if statements, different types of if statement, conditional expressions, loops, while loop, for loop, and nested loops, functions, definitions of the functions, default arguments, calling a function, functions with or without returning values, passing arguments to a function, call by value, call by reference, and recursion. Local scope. Variables defined within a function are local to that function and cannot be accessed from outside of the functions. In this example, the variable which is declared here is x is equal to 10 and the name of the function is my function. The keyword for declaring a function is def. This part of function definition we will see the last part of this part 2. Then within that function we are using the print statement, print inside the function, and the value of x will be printed, and my function, this is the name of the function which can be called here. So this kind of the function declaration, here the variable, it consists the local scope. That means variables defined within a function are local to that function and cannot be accessed outside of the function. Non-local scope, that is enclosing scope. This scope applies to nested functions. A variable defined in the enclosing function can be accessed by the inner functions. However, the reverse is not true. That is, the inner function variable are not accessible in the outer functions. For example, the same function which we defined earlier, def, the name of the function here is outer function, x is equal to 10. So the variable x, it holds the value 10. Def inner functions. So this is the function, another function inside the outer functions. So this is the nested functions. Inner function is the inside functions, and this is declared the another functions which is named as outer functions. Then we are printing inside the inner function x. Next, calling the inner function, then outer functions. So this scope applies to only the nested functions. A variable defined in the enclosing function can be accessed by the inner functions, and the inner functions variables are not accessible by the outer function. Global scope. Variables defined outside of any function or class have global scope and can be accessed from anywhere within the module. For example, x is equal to 10, def my function x is equal to 20, print inside the function x, then calling the my function, outside of the function, print outside the function x. So here the variables which is defined outside of any functions or class can have a global scope and can be accessed from anywhere in the functions. So this is the global scope. Next, if statements. Python has several types of selection statements. One-way if statement, two-way if else statement, nested if else if statements, multi-way if else statements, and conditional expression. One-way if statement. If Boolean expression, then statement. It may be a single statement or a multiple statements. So the syntax for one way if is if, Boolean expression, then statements. Here the statements, it must be intended. So this is the flow chart for a one way if statement. Boolean expression, if it is true, then the statement, a single statement or multiple statement will be executed. If the Boolean expression is false, it will come out from the loop. So single if demo, the variable number equal to eval, input, enter an integer. So input function is used to get the input from the user, and eval, it converts the input in string into a numerals. So if number percentage 5 is equivalent to 0, print high 5. If number percentage 2 equal to 0, then print high even. So you can check it whether using whether percentage it returns the remainder. If the remainder is 0, then it prints high 5. Otherwise, the second statement it will skip out from that one and it will check the another if number percentage 2, that means number if the remainder is 0, then it print high even. So if you enter the number 4, so it will print high even, because in the while you are dividing this number by 5, you won't get the remainder 0. You will get the remainder 0 when you are dividing this number 4 by 2. Suppose if you take the number 30, it can be divided by 5 as well as it can be divided by 2. So you will get both the outputs, that is high 5 and high even. Two-way if-else statement. Here this is the syntax for if-else statement. If Boolean expression colon statements, this is for the true case, else colon statements, this is for the false case. So the flow chart, it takes the Boolean expression and check whether this expression is true or false. True means statement for the true block will be executed. False means statements for the false case will be executed. For example, if number percentage 2 is equivalent to 0, then print it is even. Else print odd. So you can check based on the remainder. If the remainder is equivalent to 0, you will get the answer even, otherwise odd. Nested if and multi-way if elif else statement. One if statement can be placed inside another if statement to form a nested if statement. So here the two scenarios are given. These statements are used to check the grade and based on the scale. If score is greater than or equal to 90, grade equal to A. Else if a score is greater than or equal to 80, grade is equal to B. Else if a score is greater than or equal to 70, grade equal to C. Else if score is greater than or equal to 60, grade equal to D. Else grade equal to F. That means if any of the student get the scores less than 60, then the grade will be F. So the same thing, the equivalent is here. This is the efficient way. The second part is the efficient way for declaring the if elif else statements, that is nested if statements. If score is greater than or equal to 90, grade A. Elif score is greater than or equal to 80, grade B. Elif score is greater than or equal to 70, grade C. Elif score is greater than or equal to 60, grade D. Else F. While we are declaring the if statement, the indentation is very, very important. Otherwise, it will generate a syntax error. This is the flow chart for the above program. So if the score is greater than 90, grade A will be printed. False, then it will check either the score is greater than or equal to 80, then grade B will be printed. If it is false, then it will check score is greater than or equal to 70, then grade C will be printed. If it is false, again it will check score is greater than or equal to 60, then the grade D will be printed. Less than 60, then grade F, that is fail, will be printed. Conditional expression. A conditional expression evaluates an expression based on a condition. You might want to assign a value to a variable that is restricted by certain conditions. For example, the following statement assigns 1 to y if x is greater than 0 and minus 1 to y if x is less than or equal to 0. So the syntax is if x is greater than 0 colon y equal to 1, else colon y equal to minus 1. Alternatively, you can use a conditional expression to achieve the same results, because the previous program that takes 4 steps, if you use the conditional expression, it will be reduced to a single statement, y equal to 1 if x is greater than 0, else minus 1. So the conditional expressions are in a completely different style. So the syntax is expression if Boolean expression, else expression 2. So if the expression is true, then expression 1 will be executed. If the expression is false, then expression 2 will be executed. So that is the reason for if y is equal to 1, if x is greater than 0. If x is not greater than 0, then else part, the -1 will be executed. The result of this conditional expression is expression 1 if Boolean expression is true, otherwise the result is expression 2. Suppose you want to assign the larger number of variables, number 1 and number 2 to max, you can simply write a statement using the conditional expression max is equal to number 1 if number 1 is greater than number 2, else number 2. So suppose you have two numbers, you want to check which number is the maximum one. So if number 1 is greater than number 2, if it is true, then number 1 will be executed, number 1 will be your result, otherwise else number 2 will be your result. For another example, the following statement displays the message number is even if number is even and otherwise displays number is odd. Print number is even if number %2. So %2 it will check the remainder. If the remainder is 0, then the number is even, else the number is odd. Loops. Python consists while loops, for loops and nested loops. A loop can be used to tell a program to execute statements repeatedly. So suppose when you want to execute the repeated statements, then you may go for the loops. Suppose that you need to display a string. Example, programming is fun 100 times. It would be tedious to type 100 times a print statement. Instead of that, you can use a loop. So now you can use the how many times you want to execute this statement. So you can raise the count is equal to 0 while count is less than 100 : print programming is fun, count is equal to count plus 1. While loop. A while loop executes statements repeatedly as long as a condition remains true. The syntax for the while loop is while loop continuation condition body of the loop statements. So count equal to 0 while count is less than 100. So here this is the loop continuation conditions. Then print programming is fun, count is equal to count plus 1. So 100 times it will print. A while loop, loop continuation condition, if it is true, then the statements, the body statements will be executed until the condition is false. If the condition is false, then it will come out from the loop. So this is the flow chart for the 100 times. If you want to print programming is fun, initially count is equal to 0, then checking count is less than 100. If it is true, then print programming is fun, then count will be incremented by 1. So next time count will be 1 up to it is 0 to 99. When it is 100, then the condition is false, so it will come out the loop. So 100 times it will print programming is fun. Here is another example illustrating how a loop works. Sum is equal to 0, I is equal to 1, while I is less than 10, sum is equal to sum plus I is equal to I plus 1. Print sum as sum. So this is used to print the sum of n numbers. If I is less than 10 is true, the program adds I to sum. The variable I is initially set to 1, then incremented to 2, 3 and so on up to 10. When it is I is 10, then I is equal to I is less than 10. When the value of I is 10, that time it is false and the loop exits. So sum is equal to 1 plus 2 and so on up to 9. So you will get 45. Suppose the loop is mistakenly written as sum is equal to 0, I is equal to 1, while I is less than 10, sum is equal to sum plus I. That is here I is equal to I plus 1. It should be, it should consist with the indentation, but here it is not in that indented, so it will generate an error. So note that the entire loop body must be intended inside the loop. Here the statement I is equal to I plus 1 is not the loop body. The loop is infinite because I is always 1 and I is less than 10 will always be true. Loop design strategies. Step 1. Identify the statements that need to be repeated. Step 2. Wrap these statements in a loop like this while true statements. And step 3. Code the loop continuation conditions and add appropriate statements for controlling the loop, while loop continuation conditions statements, additional statements for controlling the loop. For loop. Python for loop iterates through each value in a sequence. Often you know exactly how many times the loop body needs to be executed, so a control variable can be used to count the executions. A loop of this type is called a counter control loop. In general, The loop can be written as follows. I is equal to initial value. So here you can initialize the looping variable I. Yi is less than end value colon. This is the, now here the loop of the body, it should be intended. Then I is equal to I plus 1. This is the adjusting the control variable. A for loop can be used to simplify the preceding loop. For I in range, initial value comma end value colon loop body. In general, the syntax of a for loop is for variable in sequence loop body. The range function has two more versions. You can also use range of A or range of A comma B comma C and so on. Range of A is the same as range of 0 comma A. K is used as step value in range A comma B comma K. The first number in the sequence is A. Each successive number in the sequence will increase by the step value K. B is the limit. The last number in the sequence must be less than B. For example, for V in range 4, 8, print of V. So the starting value is 4 and here the stepping value is not there. So the default is 1, 4, 5, 6, 7. So before the end value is 8. Before that value it will be printed. So 4 to 7. For V in range 3, 9, 2. So here initial value is 3. Ending value before 9. The stepping value is 2. So the increment value is 2. So it starts from 3, 3 plus 2, 5, 5 plus 2, 7. So 7 plus 2, 9, but it should be less than the ending value. So 7 is the last value. For V in range 1, 5, 1, minus 1. So it will decrements because the step value is minus 1. So before 1, 5, 4, 3, 2. These 4 values will be printed. Suppose the input 2, 3, 4, 5, 0, one number per line. What is the output of the following code? So number equal to 0, sum is equal to 0. For count in range of 5, number equal to E value input, enter an integer. Sum is equal to sum plus number. So the print sum is sum and the count is count. So you will get the output like this. Nested loops. A loop can be nested inside another loop. Nested loop consists of an outer loop and one or more inner loops. Each time the outer loop is repeated, the inner loops are re-entered and started anew. Print multiplication table. So display the number title, print end something. For j in range 1, 10, print j end. Print jump to the new line, then some new line that dot dot like this. Display table body. For I in range 1, 10, print I end. For j in range 1, 10, display the product and align properly. Print format I star j, 4d end. Print jump to the new line. So you will get the output multiplication tables in row wise 1 to 10, column wise 1 to 9, column wise 1 to 9, and these are the multiplication tables. Be aware that a nested loop may take a long time to run. Consider the following loop nested in 3 levels. For I in range 1000, for j in range 1000, for k in range 1000, perform an action. So the action is performed 1000 times into 1000 times into 1000 times. So 190 times. It takes 1 millisecond to perform action. The total time to run would be more than 277 hours. Functions. Now we will discuss definition of the functions, default arguments, calling a function, functions with or without returning values, passing arguments to a functions, call by value, call by reference. Functions can be used to define reusable code and organize and simplify the code. A function definition consists of the function's name, parameters, and body. The syntax for defining a function is as follows. Def, function name, list of parameters, then function body. Define a function. Here I am going to define a function which is named as max. So def max, it takes the two arguments number 1, number 2. So these two arguments are known as formal parameters. The name of the function here is max. Def is the function header. Within that, the body of the function, here I am going to check if num1 is greater than num2, then result is num1, else result num2. Return the result. So the function, it returns the sum of the values, returning value. So invoke a function. How to invoke a function? Z is equal to name of the function is max and it takes two arguments x comma y. So now while you are invoking a function, the function holds the actual parameters, that is known as arguments. You can define a function and invoke it with arguments. A function contains a header and body. The header begins with the def keyword followed by the function's name and parameters and ends with a colon. The variable in the function's headers are known as formal parameters or simply parameters. A parameter is like a placeholder. When a function is invoked, you pass a value to the parameter. This value referred to as an actual parameter or argument. Parameters are optional, that is, a function may not have any parameters. Default arguments in Python. Python allows functions arguments to have default values. If the function is called without the argument gets its default value. Default arguments. Python has a different way of representing syntax and default values for function arguments. Default values indicate that the function argument will take that value if no argument value is passed during the function call. The default value is assigned by using the assignment operator of the form. Keyword name equal to value. So the syntax def is def function name parameter 1, parameter 2 is equal to default value 2, parameter 3 equal to default value 3, and so on. Def students first name, last name is equal to mark, standard is equal to fifth. So here the three parameters are defined, but two parameters has the default value. Last name equal to always mark, standard is equal to fifth. Print first name comma last name comma studies in comma standard. What standard you can give it. So first positional argument student John, then three positional arguments student John Gates 7th, two positional arguments student John Gates student John 7th. So you will get the output John Mark studies in 5th standard, John Gates studies in 7th standard, John Gates studies in 5th standard, John 7th studies in 5th standard. Calling a function. Calling a function executes the code in the function. In a function definition, you define what it is to do. To use a function, you have to call or invoke it. The program that calls the function is called a caller. There are two ways to call a function depending on whether or not it returns a value. If the function returns a value, a call to that function is usually treated as a value. For example, larger is equal to max of 3, 4. It calls max of 3, 4 and assigns the results of the function to the variable larger. Another example of a call that is treated as a value is print max of 3, 4, which prints the return value of the function called max 3, 4. Returns the maximum of two numbers def max number1, number2. If num1 is greater than num2, result equal to num1, else result equal to num2. Return result. Def main I is equal to 5, j is equal to 2, k is equal to max of I comma j. So this statement calls the max function. Print the larger number of I and j is k. Then you are calling the main functions. So the larger number 5 and 2 is 5. When a function is info, the control is transferred to the function. When the function is finished, the control is returned to where the function was called. Functions with or without returning values. The previous example shows functions with return values. Return the max of two numbers. So it will return the maximum value. How to define and invoke a function that does not return a value. Such a function is commonly known as a void function in programming terminology. Def print grade score. If score is greater than 90, print A. Elif score is greater than 80, print B. Elif score is greater than 70, print C. Elif score is greater than 60, print D. Else print F. Def main score equal to eval, input, enter a score, print the grade is end, print grade score. So this function is commonly known as void function because it doesn't return any value. function with return value, return the grade for the score. So here you can use the return statement to return the functions. Gets def get score of get grade of score. If score is greater than or equal to 90, return A. Elif score is greater than 80, return B. Elif score is greater than 70, return C. Elif score is greater than 60, return D. Else return F. Def main score equal to eval input enter a score. Print the grade is get grade score. Calling the main functions. The getGrade function returns a character grade based on the numeric score value. The getGrade function returns a character and it can be invoked and used just like a character. The printGrade function does not return a value and it must be invoked as a statement. Passing arguments to a function. Information can be passed into functions as arguments. Arguments are specified after the function name. Inside the parameter, you can add as many arguments as you want, just to separate them with a comma. Def my function fname colon print fname plus refness. My function email, my function Tobias, my function Linus. So it will return all the values. Call by value. In Python, the common way of passing function argument is through call by value. This means that when you pass a variable to a function, you are essentially handling over the actual value of the variable itself, not the reference to the object it is pointing to. Consequently, any changes made to the variable within the function don't directly affect the original variable outside the function. In this example, the Python code demands state call by value behavior despite passing the string variable jigs to the function. The local modification inside the function does not alter the original variable outside its scope, emphasizing the immutability of strings in Python. Call by value example, string is equal to jigs, def test string colon, string is equal to jigs for jigs. Print inside function comma string. Then test calling the function parameter string, print outside the function comma string. So it will print inside function jigs for jigs, outside the function jigs. In this example, we will discuss about the call by reference in Python. The Python code illustrates by call by behavior. The function add more modifies the originality list, mylist, by appending an element, showcasing how changes made inside the function persist outside its scope, emphasizing the mutable nature of list in Python. Def add more list dot append of 50, print inside function comma list. Mylist 10 20 30 40, add more mylist, print outside function comma mylist. So inside function already it consists 10 20 30 40 50, then already because 50 is appended to the existing list, outside function 10 20 30 40 50. And the last part of this unit is recursion. Recursion involves a function calling itself directly or indirectly to solve a problem by breaking it down into a simpler and more manageable parts. In Python, recursion is widely used for tasks that can be divided into identical subtasks. So here, finding the factorial of a given number. So here, def is the keyword for the function definition. Factorial is the name of the function. N is the parameter. If n is equal to 1, return 1, else return n into factorial of n minus 1. Print factorial of 5. So factorial is the name of the function which we are using here. Recursion means a function which call itself. Here the name of the function is factorial, and while we are returning the function return n into again the factorial function that call itself. So suppose if we want to find the factorial of 5, then it can be computed. 5 factorial is equal to 5 into 4 factorial. Again 4 factorial can be computed. 5 into 4 into 3 factorial. Again 3 factorial can be computed. 5 into 4 into 3 into 2 factorial. Again 5 into 4 into 3 into 1 factorial. So you will get 5 into 4 into 3 into 2 into 1. The final answer is 120. So the recursion, that means a function which call itself.